Replay. And this is K.Ramisha Rani from AICL. So in today's topic, we are going to see the future selection and dimensionality reduction for machine learning algorithms, right? And followed by this, we are going to discuss about the deep learning artificial neural network as well as convolutional neural network. After that, we are going to see the recommendation system, right? So how many of you are aware about machine learning? So first, let's get introduced to basic topic, then we'll start proceeding with the concept. So I need several answers from you all. So do you all aware about what is machine learning? You can type S in the comment box. So based on your reply, I will start my session and I will start my content delivery up to you. Yes, okay. Do you know what is model? When I say model, do you have visualization for it? So what are the question I'm asking here is entirely the necessary topic to understand. Okay, so yes, so I need answer from everyone so that I will take the majority. Okay, yes, very good. What about weight and bias? Weight and bias? Yes. Okay. So you all aware about what is model as well as weight and bias. So with the help of this, we are going to learn how we can go for our future selection. Then do you know difference between regression and classification problem statement in machine learning? Regression and classification problem statement in machine learning. So those who are don't know, at least don't have any visualization, you can type no in a comment box so that I can know how many of you know and don't know. Okay, right. So anyhow, I will give a little introduction about these topics. Then I will start with, then only you can understand what is the purpose of feature selection and dimensionality reduction. Okay, so let me start presenting my screen. So first we have to understand what is machine learning is, right? Machine learning, right? So why they have kept name like machine learning? Then there are three types of segment. One is supervised, another one is unsupervised, then semi-supervised, right? So under supervised, we have two segregation part. One is regression and another one is classification. So quickly tell me, actually, what is the overline of machine learning? Why we have to go for machine learning? Any guesses? Any guesses? Why you have to go for machine learning? I need one line answer for this. Why we have to go for machine learning? Any idea? Please comment it in comment box, in chat box. Make machine to learn and predict. Optimization, time saving to teach machine for our application. Right, very good. So one line, if you want to tell about machine learning, is for prediction. Literally, it may be for future prediction. Otherwise, it may be for past prediction, right? So when we are saying that it is fully for prediction, right? How the prediction is possible? How the prediction is possible in machine learning? So you can predict in two ways. Your output variable may be in numeric, right? For example, if you want to predict a house price prediction, so literally answer going to be in a numeric value, right? So if you want to predict some classification type, you are forwarding one image, then you have to classify what kind of image is that. Like it may be a dog image or cat image. So one of the prediction variable is like categorical data. Your output variable, another type is categorical data. So when your output variable is numerical, then you can say that is a regression, right? So when you say your prediction is going to be a classification like yes or no, positive or negative, so in that case, okay, in that case, you can say that problem statement comes under classification, right? So why we need such type of two different statement for prediction? Because if it is regression problem statement, your validating parameter is fully depend on the error, the lowest error, minimum error. What is error? Between the actual point minus predicted point. So for classification, the validating parameter is fully depend upon the accuracy. So I hope you have aware about confusion matrix, right? Confusion matrix. Confusion matrix. So we work for to, in case of regression, we work for to minimize the error, right? To minimize the error so that you can say your model is working good, right? So when you come for classification, you have to improve your accuracy, right? So to improve your accuracy, we'll do a lot of model improvement. Right? So you have to understand whenever you are going to deal with machine learning, you should know what is regression. First, problem identification is must. So based on your output variable, you can easily identify whether the problem statement comes under regression or classification. Again, whenever you see, okay, identify that as a regression, then your whole concentration of minimizing the error. If it is classification, the whole concentration of increasing the accuracy. Right? So now tell me, what is model? Actually, what is the visualization of model when you get? So in addition to this, machine learning is the application of mathematical department. Okay. Machine learning is a pure application of mathematical department. So let me tell you very shortly how you can visualize the model. Okay. So for example, here I'm taking the linear regression formula. Okay, for straight line equation, linear regression formula, nothing but y is equal to w x plus b. W is weight, x is input variable, and b is intercept. So you are going to perform linear regression, right? Consider you are going to perform linear regression. For that linear pattern, you know the formula y is equal to wx plus b. So when you find, okay, when you find W and B, this will convert like for here I'm giving the dummy data like 0.3 x plus 25. So when your formula is converting into this format, when you're calculating your weight and bias, this particular equation becoming a model. So whenever you are reading about model in some article or book, your visualization should be like, okay, you have calculated weight and bias from your particular data set. Because if you substitute, so using this model only, you can do the future prediction, right? You can do the future prediction. Simply substituting your input so that you can get your respective output. This is nothing but the future prediction, right? This is nothing but the machine learning. Okay, so in my point of view, machine learning is nothing but calculating the weight and bias based on the pattern. So choosing the formula is the first one. Based on your data pattern, you have to choose. If it is a linear pattern, then you have to go for linear algorithm. If it is a data set is a non-linear pattern, then you have to go for non-linear algorithm. Right? So based on that segregation, you can select your algorithm. So algorithm is nothing but simply a max formula, what we have studied so far. Right? And converting weight and bias is a model. Right? So what is the purpose of weight? Quickly tell me, what is the purpose of weight? What is the purpose of weight? What is the purpose of weight? So purpose of weight is based on learning importance of attribute, contribution towards computation, make machine to learn, then based on attribute. So exactly I want what kind of visualization you have when I say weight. What is the importance of weight? Please quickly type it in the comment. If you don't know, you just type no in the comment box. So just I want to know what's your opinion about weight, because if you understand what is weight bias model, then you have done with machine learning. If you understand that, then it's over. Then it is easy for you to understand all the concept and how this actually the machine learning is working. So I'm not getting any replay. Okay, I consider, let me explain it. So weight is nothing but, consider this is your data set and your pattern are like in this way. Okay, in linear pattern. So when you identify that your data is in a linear pattern, you are choosing your linear algorithm. You are choosing the linear algorithm. So how this is going to make us for future prediction? So you have to find out that in which pattern this data is getting increased or decreased. So as of now, for this picture, it is in increased manner. So you have to find what is the difference between these points. So if you find the ratio, in which ratio this data point is getting increased, then you can easily go for future prediction. So that ratio finding is nothing but weight. Okay, that ratio finding is nothing but weight. Then what is bias? So if it is a straight line, then it should have some origin, right? So to start the initial point is called bias. To start the initial point is called bias. So machine learning is fully depend upon the data pattern. So this is for non-linear, this is for linear. What if your data set is so messy? and you want to make some prediction for such type of data set, then you have to go for non-linear algorithms like SVM, then decision tree, random forest, such kind of thing. But the concept of weight and bias remains same for all the algorithm. I can say even for NLP, even for deep learning, it's same. So the weight is nothing but how each variable is, in which ratio it's getting increased or decreased, in which pattern it is following through. So this is the overview that I have to give before starting this lecture, right? Then what is the importance of feature selection? So we know that machine learning is for feature prediction, right? So how this is going to happen? Why we have to do feature selection and dimensionality reduction, right? Consider on problem statement, right? 1 minute. Okay. So consider you have 100 columns, like input 1, input 2, input 3, input 4, input 5, like up to input 100. So based on this 100 input, you have one output variable. So you have Pca accuracy. Like consider this is a classification problem and you have accuracy of 95%. Consider this is a medical application. You are going to do one medical machine learning model for kidney disease. Consider for kidney disease and you have 100 columns and you have to predict whether this person is going to have kidney disease in future. Your literal answer is positive, otherwise negative. Okay, you have 100 columns and model accuracy is 95. So your higher official is asking you to deploy it in for real time. So you are going to install in a hospital system and one sister is going to take in charge for that. So with Pca UI, we are going to deploy it in a real time. So to make this prediction, you have to enter this 100 input. Is this feasible? Is this feasible? Is this cost effective? Because obviously, if it is a medical, it's going to be each blood test report. So each test will cost around some amount. So obviously, if you go with this 100 input variables, then it's going to be the waste, right? No use of creating machine learning model. So literally, we have to reduce this 100 column into feasible and we have to select very important feature. So we say this input as a feature. So whenever you hear about feature selection, then your mind should strike, okay, this is all about, they are talking about input columns. So in machine learning, for one parameter, we have several names, right? So literally, we have to reduce the column, 100 column into 5 column, so that easily we can enter the test report and as well as it is feasible, as well as it is a cost effective. Do you all agree that? So this is the main motto of feature selection. So how we are going to select that the most important 5 columns from this 100 columns. And for this 5 columns, how it's going to give the accuracy. So this is all we are going to look into this particular session in detail. Are you all ready? If you are ready with this session, you can type ready so that we can move to the actual session of this webinar. So far I have covered what are the needs and why we are going for feature selection and dimensionality reduction. Okay, yes ma'am. Okay, great. I hope you are all have more interest to learn this. So thank you so much for your interest. So we'll start with first, let me give the difference between what is feature selection method and what is dimensionality reduction. So I told that the feature selection is input column selecting, right? Then what is dimensionality reduction? What is dimensionality? I said for one variable, like for one particular concept, we have several names. So we used to say, right, input column as input variable. Then we can say that is a feature selection. We can say that is a feature. We can say that is a dimension also. Dimension also. If you have one dimension, which means only one column, then it is a one dimension. If in previous example, I told we have 100 columns, 100 inputs, then 100 dimension. That is the only visualization you can have for it. Now we have different methods, feature selection method and dimensionality reduction method. So feature selection is, it select the important feature among the input features variable. So previously I told we are having 100 columns. From 100 columns, we are going to take only important feature of 5 columns, right? So again, based on the user input, it select the number of feature. So first, if you are doing some PhD work in this particular domain in machine learning, I hope nowadays all the papers are asking with one of the comparison with the deep learning algorithm, right? In AI world. So you can go with the playable parameter of this. First, you can check the accuracy with by selecting only 3 columns. You're getting the one model. For this respective model, you can get accuracy like 90%, right? Then you are checking, with the help of queries, you are checking for the 4 column. So here user input is nothing but how many columns you want to check for it. So based on that, we can go for the input specification. So our final output is no change in the data value. So instead of 100 columns, we are going to select only 5 columns from that 100 columns. That is feature selection method, right? In dimensionality reduction, input values are converted into a cluster feature. So instead of selecting among the 100 features, we are going to convert all these 100 features into a cluster feature, right? So based on the user input, it selects the number of cluster you want. So there is a change in the data value. So the exact difference between the feature selection and dimensionality reduction is there is no change in the data value, but in dimensionality reduction, there is a change in the data value. So we'll see how feature selection method works and how dimensionality reduction works. So this is the main comparison that you have to know before getting into a topic. I hope now you have overview about what is feature selection and dimensionality reduction, right? So let me give some overview about the feature selection method, right? So here we have 4 inputs. So after feature selection method, you're going to get only 2 inputs. So based on this input, the size and age is considered as the most important feature. So instead of 4, I'm going to take only 2. So this particular concept is literally to intuit how feature selection works. Actually, if it is 4 input, no need to go for feature selection. But anyhow, even it works for 1,000 of columns, right? This is the same concept. For dimensionality reduction, I'm using the same data set. So here you can see after, so one of the dimensionality reduction is Pca method. So here I want to know how many of you from which department. Please type your department in the comment box. CSE, great. What about others? Computer applications, great. CSE, good. Computer applications, great. So I hope a majority of you from computer science department. So if you are from EC department, you may have know about what is principal component analysis. That's why I asked you. No issues, right? So after dimensionality reduction method, you can see we have completely changed the dataset value.
we have completely changed the dataset value, and this is the principal component 1, principal component 2, principal component 3, and principal component 4. If you want only 2, you can specify 2 in your programming so that you can do only first 2 principal component. So literally, entirely we are changing the data values into a separate, using some Pca calculation, we are changing the entire value. Right? We'll see how it works. So now I'm going to tell you what are all the feature selection method. So feature selection, first method is select K algorithm. It fully depends on chi-square and RMS value, root mean square value. Okay, then recursive feature elimination. So what is recursive feature elimination? We'll see in detail. So this is fully depend upon each variable with output. So here I'm telling variable is input column. Okay. So next algorithm is future importance. So changing each variable and changes in the output. Then forward selection based on the correlation and backward selection based on the correlation, right? So these are the future selection method, necessary future selection method that you have to know for, right? So in this lecture, we are going to discuss about what is select K, recursive, and future importance. So algorithm of dimensionality reduction is principal component analysis, linear discriminant analysis, then kernel Pca. So we are going to see nearly 6 working principle, how this is going to work, how it's going to select your future, right? So consider this is a data set. We have 15 columns and 215 rows, right? So first we are going to apply this method for select K algorithm. So here we are going to use chi-square as a final validating parameter. So this is your input column. Consider this is your input 1 and this is your output. So in this select K algorithm, first we are going to introduce only one input. So we are going to create a machine learning model with the help of this chi-square, okay, between this input 1 and output. So at the time you may have the chi-square value was 0.8. So it will store it in the memory. In second step, it's going to add one more input to that model. So input 1, input 2, and output. So now the accuracy was increased. 0.85. Okay, 0.85. It got increased. So based on by including, so in next case, we are going to add one more input 2, input 3, and respective output. So now you can see the chi-square value is 0.75. It got reduced when you add this one. So we got the better result when we had the 2 input. So we don't need to add this input in this model, so that you can consider from that 15. So the process goes on. It will check with all the combinations of adding the input, and it will check with the respective validating value. For as of now, we tested with 3 input. When you add input 1 and input 2, you had 0.85. So that we can conclude that the future input 1 and input 2 is an important feature that's giving the maximum output, right? So again, when I add 4, now my accuracy got increased to 0.90, right? A minute. Sorry for the interruption. So now when you add this 4 input, you got accuracy like 0.90, 0.90, so that we can confirm that okay, we add 4 for 4. When you give 4 as a input feature selection, we get 90, so that we can fix this as a perfect model for this particular data set. So if you are in a research field and you want to check, you want to give some statistical report for your problem statement, you can make with the several combinations, like algorithm is best, select K best. Okay, you are applying with the Chia square. What is the value? What is the accuracy of the Chia square? And respectively, you can change, instead of Chia square, you can change the parameter to RMS value. So you can check for when you give input is equal to 2 and what is the Chia square value. For example, 0.90 and RMS is giving 0.80. And if you are checking with when you are giving input as 3, when you are necessary to check for 3 input variable, at the time it may give 0.75, this may give 0.90. So again you are checking with the possible way until you get the good result. So based on this table, you can select for this algorithm. You can select from this table which one is working better. So as of now, for select K, when user input is 3, RMS's value is giving 90. So you can choose this one as a future selection for your research work. And still we have many more future selection method. And if you are in a research field and you have to give some report, like for your paper publication, you can check with all the algorithms. So literally in this field, if it is a real-time project, we check with all the possibilities. We will not stick into one algorithm. We'll check with all the possibilities and we'll choose the best one. Right? So now we are going to see the next one, the recursive feature elimination. So the recursive feature elimination. Now we'll see how this recursive feature elimination works and how it differs from select K algorithm. So again, we are going to take one input and one output. Now we are going to check with algorithm. Here, in previous case, we used the Chia square as well as RMS value. Here you are going to use literally a machine learning model. If it is regression, you can check with all the regression algorithm. So here I have mentioned for machine learning algorithm 1, we are getting 0.78. So for the same set of input, we are getting 0.80 when you are applying with the machine learning algorithm 2. In this algorithm may be anything. So literally this is for you to give the overview how it works. Okay. So now I am adding the second input variable and checking with respect to the output. Now you can see the machine learning algorithm is 0.78 and machine learning 2 is also 0.80. So why they have named recursive feature elimination? So for this recursive feature elimination, you have to understand the two important concepts. One important concept is you can check with all the regression algorithms for this particular data set. This is one point that you have to understand. The next point is why they have named recursive feature elimination. So obviously here our main goal is to eliminate the repeated feature. So how we are going to find this feature is a recursive feature, which means the repetitive feature. Any idea? Any guesses? Any guesses? Any guesses how we are going to find that this is a repetitive feature? You can type anything. Yes, no, anything. You can type anything. right? So the recursive feature elimination, how they are finding out this. So previously you can see when we have one input, at the time also we had 0.78 and 0.80. So when you add the second input, at the time also your accuracy doesn't changed. So that you can confirm including of this feature is no use. You don't have any changes, whether it hasn't decreased or increased, so that you can confirm that this feature is not important. Like this is one of the concept you have to understand as per the name, like recursive feature elimination, right? So here you can see we are adding the third parameter to the problem statement. Here you can see we have decreased our accuracy for first algorithm and increased the accuracy for the second algorithm. So there is an abrupt change when you add the third parameter. So this is the most important parameter. You should not remove this. So likewise only you can eliminate your unwanted feature. So this is the tabulation that you can go for. You can type algorithm 1 like linear regression, multiple linear, polynomial, support vector, right? And the respective value. For n, how much? For when n is equal to 3, how much? Like that you can make some table. From this table you can take your best one. So the next one is feature importance. So do you have any doubt up to this? Do you have any doubt up to this? Please type it in the comment box. So no, madam, but comparing with deep learning is a little bit confusion to me. So very good question actually, but comparing with deep learning, little bit confusions to me. And machine learning is entirely different from deep learning. Okay, I will tell. Do you want to know what is the difference between machine learning and deep learning? Because I hope this is the right time to tell how. Next session we are going to see how deep learning works, right? So understand one thing, machine learning is entirely different from the deep learning. So this is the exact procedure how you can select a feature selection in machine learning. But in deep learning, feature selection is automatic. You don't want to go for any feature selection method. Right? Okay, so in next lecture, we'll continue the deep learning. Now let me finish this one, right? Okay. So future importance is nothing but based on the coefficient, we are going to select the best one. So this is input feature 1. So for input feature 1, you can see we had R square value like 0.72. For this also, you can check with the model. You can use any model you want. So when you add higher secondary mark pass mark and your R square is get increased 0.80, but here there is no elimination part, right? So based on, so for 10th mark your coefficient may be like 10.0. For higher secondary mark it may be like 11.0. So this is giving you the highest coefficient so that you can select as per the name future importance. You can select this is going to play the vital role. For example, I'm telling you here. Clear? So this is a normal check based on respective machine learning model. We are going to select based on the coefficient value. And there is one more concept under this future importance, that is permutation concept. I hope you are aware about permutation, right? So in using this permutation concept, we can effectively select our future important for the problem statement. Right? So permutation is nothing but it's going to change the input value. This row will be swapped. All the rows will be swapped between this column, and it's going to find whether the respective change in the salary. So after changing these rows, interchanging the rows in this particular column, for example, I'm telling you for this column, this is the logic. It happens for all the column. And we are going to check with the salary. So after changing this input, we are going to create a model and we are going to see the accuracy. If it is sudden change with the previous one, we can say this is the most important future, because when you change the value, it's giving abrupt change in your accuracy, in your model performance, so that you cannot remove this one. So there is another case. Okay, there is another case. Even though if you interchange this value, your model accuracy will not be changed. So that you can consider that by changing those value, the model performance is either not decreased nor created. Right? So that we can conclude that we don't want to use this future for the model performance, so that we can remove. So there are two conditions under this future importance. Right? So these are the difference between each algorithm, how it works. Right? So the next is we are going to jump into dimensionality reduction. So here you can see exactly we are going to, if you consider this is the important future, exactly with the same value we are going to take this to build the model. But in dimensionality reduction, that is not possible. So before understanding what is dimensionality reduction, first you have to understand what is scalar and vector. So do you have a visualization about scalar and vector? So what is scalar? Type it in the comment box. So what is scalar? Please type it in the comment box. Any idea? So measure between 0 to 1. Okay. Raw data size. Okay. So whenever you hear about scalar, so in from our school to college, we have studied that scalar is a magnitude and vector is a magnitude and direction. Do you have exact visualization of how scalar and what is magnitude? So here I have represented, if it is a scalar, only it is going to give you the measurement. From this name, you can easily understand that. Scalar, scaling is nothing but measuring. So why they are representing with the magnitude? So if it is 10, you can see this is big size. So comparative to 5, this is in a small size. So as per your value, you can see there is a change in your visualization. Right? There is a change in the visualization. Right? So the scalar is nothing but all about the size, whether it is big or small. Right? So this is the first visualization you have to get for when we are talking about scalar. So then what is a vector? So vector is nothing but the magnitude and direction. Do you have any visualization for this? So I have told you how magnitude looks like. Now tell me how vector will look like. How you can correlate with it. Any idea? So here, in addition to the size, we are going to determine in which direction it's going to be, right? So consider this is a direction and magnitude is 5 and this direction is towards left side. Consider this arrow point. The size is, okay, magnitude is 10 and direction is towards the left side. So here the magnitude is 2 and direction is downside. This is magnitude is 8 and direction is upside. So here you can see various sized arrow mark which represent with the direction as well as the size of this arrow. So this is a little bit as a very blended overview about the magnitude and direction. Right? So how you can relate this vector with the data science, with mathematical form? So I hope we all know about how to plot 2D graph. Okay. So if this is a point, we will represent using like 2, 3. So this is 2 and 3. We are plotting like 2, 3. And this direction is towards, we can say this is a first quadrant, right? This is in first quadrant direction and magnitude is the distance between from origin to this point is 4. So we are calculating the distance, nothing but magnitude as well as the in which direction it's moving towards. So if you take this data point, you can make a point like 5, 3. No, 5, 4. Okay, now comparative to this point, the distance is increased 8 centimeter and this is also towards in the same direction. So consider you are in a 4 quadrant and your point is here. Okay, and your point is here. Now you can tell me your direction. Direction is towards downwards. So when you have 2 points, literally you can imagine the 2 vector. 2-dimensional vector going to be, it involves the 2 plotting. But in a scalar, it is going to work only with one value, only 2. If it is vector, it is at least we need more than one value. So vector is not only it have 2 values, it may increase up to infinity. Based on your problem statement, if you want 100 vectors, then it will keep on increasing like this. So visualization of vector should be like this, right? So the next term is a dimension. So any idea about dimension? So we have 0 dimension, 1 dimension, 2 dimension, 3 dimension and n dimension. So what is 0 dimension? So 0 dimension is dot. Dot is a 0 dimension. We don't have to say, we don't have any representation for this 0 dimension. So for 1 dimension, you can say 1 line. So for 2 dimension, you can say 2 lines, x-axis and y-axis. So for 1 dimension, we are going to have 1 value. For 2 dimension, we are going to have 2 value. For 3 dimension, we used to represent like this. So visualization, like in mathematical representation, we can go for 2, 3, 4. 1 minute. right? 2, 3, 4. What if n dimension? Up to 3 dimension, you can visualize it because we are living in a 3-dimensional world, so that we can experience 3 dimension. But we cannot able to visualize how 4 dimension will be, right? So that instead of visualization, if you want to represent in a mathematical form, then you can go like 2, 3, 4, 5. So this is 4 dimension. If it is 100 dimension, then you can go like up to 100 values. So how we are going to relate this dimension to a data set? Any idea? So this is a literal base for dimension. How we are going to apply this vector concept to the data set? Any idea? So I told vector representation is going to be 2, 3, 4, 5, 6. For simply I'm writing those number. So this is going to act as a input variable 1, column 1, input variable 2, column 2, input variable 3, input variable 4, and input variable 5. And this is for entry 1. So if you are going to expand like matrix with several value, so here we are going to map matrix into a data set also. So I hope now you got what is a dimension is. The dimensionality reduction, already we have feature selection methodology, then why Pca? So I told under dimensionality reduction, we have 3 algorithms. One is principal component analysis and another one is linear discriminant analysis, then kernel Pca. So now we'll start understand how principal component analysis work, how Pca works, and how it is going to change our entire value, right? So consider as of now, we'll take only 2-dimensional, which means 2 column, and we'll try to understand the whole concept with 2 dimension, but you can map it, these concept to when you're involving with the 100 columns. Even the n-dimensional columns. This is the exact principle it's going to happen, right? So this is the exact representation of, okay, this is the exact representation of how the 2 variable is getting plotted in this particular 2 dimension. So what is next step? So the next step is we have to drag this, okay, we have to drag this whole data set towards the origin. We have to drag this data set towards the origin. But there should not be any changes between the data points, distance between these 2 points and distance between these 2 points. So which mathematical formula will help you to get such type of drag? Any idea? Any idea? How we are going to drag this whole data set towards the origin? Here you can see, right here you can see we have dragged the whole data set towards the origin. Which mathematical formula is going to help us? So I hope you all know about covariance. So covariance is nothing but, okay, nothing but taking average of whole data set, and we are going to subtract each data point from that value, so that you can easily convert that into a origin. So when you have shifted the whole data set into an origin, so from the origin you can make one regression line. So that is going to be your first component. So this regression line is going to be like this. So most important component. So as of now, understand what is it, then I will tell you the mathematical work, how this particular, why we can say this is a regression line. We have option like you can go for this, you can put like this, and there are many possibilities, but exactly we have to select the perfect direction, perfect regression line, right? So when you draw your first component, your second component always is going to be on the 90 degree. Right? So this is your first component. It should be a 90 degree of your second component. So you're going to take this value as your first principal component. This is your cluster 1 and this is your cluster 2. Right? So based on this only, you can change your entire value. Right? Even if you want PCA 4, then you can draw a line over here. Then perpendicular that you have to draw another line. PCA 3 and PCA 4. So based on your wish, you can get many number of dimensions. So here you can see. So the main important concept is you have to drag your data into a center. That is the first point for PCA. So this is the overall working principle of, if you want to visualize it, this is the overall thing. You may ask me one question, how exactly that regression line is formed? How we are going to, there is a many possibility of drawing regression line. How we are going to select the first most clustered regression line? So with the help of eigenvalue and eigenvector. So how many of you have heard about this concept, eigenvalue and eigenvector? Please type it in the comment box. Just I have curious to know how many of you know about this concept. That's it. No idea, ma'am. Okay, good. What about others? So if you are from mathematical background, you may have know about this one. If you are from easy background also, you may have heard about this. So there is no chances of CSE department people, I hope. So no idea. Okay. So here we are going to use the mathematical term eigenvalue and eigenvector. So eigenvalue is a scalar. Eigenvalue is a scalar which determines the increased size or decreased size. Okay. And eigenvector is all about the direction, magnitude as well as the direction. Now we are going to find eigenvalue and eigenvector for a data set. Right? Right? So consider this is a data set. Okay, first step, you have to put it in a covariance. So this covariance is going to give you the new data set. So you have to consider that as a matrix. I hope you all know about matrix, how it looks. So based on this bracket, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is column 1, column 2, column 3. So this is the first step. So after finding out your covariance, here we are going to understand with the 3 cross 3 matrix. And this is the same working principle even you work with 100 cross 100 matrix, which means 100 columns into 100 columns. For example, to enlarge the increased column, I'm using 100 cross 100. So data set to data set, it may vary. Right? So let's understand with 3 cross 3 matrix. So this is the after the process of covariance matrix. Covariance matrix 4, 3, minus 2, 6, 10, minus 6, 10, 13, minus 8. So there is a formula to find your eigenvalues. Right? The lambda I. So determinant of A minus lambda I is equal to 0. Right? So what we are going to do, this is a matrix A minus lambda, then we are going to put this identity matrix. So based on this data set, understand clearly, based on our covariance data set, we are going to find our lambda value. So if it is 3 column, then you are going to find 3 eigenvalues. Right? So after some calculation, okay, the first eigenvalue is 0. First eigenvalue is 0. Second eigenvalue is 2. And third eigenvalue is 4. So let me change the color. Okay. 1, 2, 3. So now we found, okay, eigenvalue purely depends on our data set. Okay. So the next one is we have to find the eigenvector. So we have to find eigenvector for each scalar value. Understand? So first we are going to use the lambda 1 is equal to 0. Right? And this is the formula to find that particular vector. So finally, after some calculation, we have found v1 is equal to -1, -1 and 1. This is the vector 1 respective to this scalar. Right? So now for value 2, lambda 2. Finally, we got vector 2 with respect to lambda value 2 is 1, -2 and 1. Right? So now value 3. So for value 3, we got vector as -3, -5 and 3. So finally, we found eigenvalue as, okay, eigenvalue was 0, 2, 4. The respective eigenvector is -1, -1, 1. The next one is, what is the next one? 1, -2, 1. Then -3, -5, 3. So this is the respective eigenvector for the respective eigenvalue. So how this is going to help for PCA? Why they have named principal component analysis? Any guesses? Any guess? Any guess? So I told eigenvalue is a scalar. Now we know the purpose of scalar. Scalar is going to tell you about the measurement. So in this value, which one is the highest one? Tell me, in this 3 scalar value, which one is the highest one? All you are with me? So Kaviyarisi ma'am told 4. Okay, what about others? What about others? Which one is the highest measurement value based on this 3? 4. Very good. So we understood that eigenvalue for this particular data set is 4. So what is the respective vector for that 4? Tell me, which one is the respective vector for this 4? Quickly type it in the comment box. -3, -5, 3. Very good. So this is our PCA 1. Principle. What is the principle? The most important one. What is the component? This is the component. That's why they have named principal component analysis. That's why they have used the eigenvalue. Nothing but the scalar. So what is the next principal component? 2. What is the third principal component? 0. This is your changed value. This is our changed column value. Now you understood what is PCA? Is it clear? How PCA dimensionality reduction helps for dimensionality reduction, and how eigenvalues and eigenvector helps for dimensionality reduction? Is there any doubt in this particular concept? Any doubt? No, ma'am. So using these two concepts only, you can find your principal component. and this is going to act as a column 1 when you get output. So for this input value, you can do calculation, like you can develop your machine learning model and you can check for accuracy. If it is good, you can go for a real-time deployment. Right? So then what is linear discriminant analysis? How the linear discriminant analysis works? So first we'll understand the naming of this. What is linear? That is going to be the straight line with some slope. What is discriminant? So discriminant is nothing but it's going to differentiate, and we know what is analysis is. So simply, literally, we are going to do the classification process of this linear discriminant analysis. So here you can see this is before LDA and this is after LDA. So based on this regression line, it got segregated the both. So when it got segregated, this direction is going to be your LDA1. So LDA1 have the better segregation part. So this is the probability density of this particular blue color line, and this is for the red color dot. So LDA2 is not that much effective because that is overlapped. If you are seeing in this perspective, and if you want to draw the diagram, probability density function, then it's going to be in this way. Right? So the next one is how it works. So linear discriminant works with, if it is two category, in that it start working with the finding the centroid. So based on the centroid, it creates one line. So based on the distance, it creates the segregation part. Right? So here you can see how it works. Though this is a general centroid, as well as each category will have centroid. So how KNN works, which means K means work in several ways it works. Okay. Now you can ask me the difference between, what is the difference between the Pca and Lda? So Pca does not segregate, okay, does not segregate the data set. Generally, it calculates from this regression line what is the distance between the data points. Okay. But LDA will do classification. Will do classification and make a difference between the groups, makes difference between the groups. So that you can use Pca for regression problem statement and LDA for classification problem statement. Clear? Then what is kernel Pca? So when Pca is segregated by linear line, then this is for linear pattern, linear algorithm. So when you are making that segregation part with non-linear pattern, then you can go for kernel Pca. So whenever the kernel involves in the concept, then it's all about non-linear. So any doubts so far? So quickly, let me run some programming, how we can do filter selection. And how we can get the different model. Any doubt? So I'm opening the spider. It may take a little bit time. So in between that, if you have any doubt regarding what we have discussed so far, you can ask now. Any doubt? Yes. Okay. So first, let me tell about. Will show you how feature selection works. Then I will show you how PCA works, right, in programming. So here I have taken the chronic kidney disease prediction. So after the pre-processing, I have separately saved the file. So let me run this particular code snippet. So first I have to make this as a working directory. So now let me run. Okay. So I'm importing the necessary libraries. So this is Python and I'm using Spider IDE. I hope you all know about this. Right? So I will show you how this data set is looking like, right? So we have nearly 25 columns and one output. This is a classification problem statement. And here you can see we have age, blood sugar, blood pressure, sugar, then AL, SU, many biological term like medical term. And we have categorical data as well as the quantitative data. And the pre-processing is a separate domain. Okay, if you have any other chance in future, I will tell you how to do pre-processing. As of now, so using this particular code snippet, I can change the categorical data into a number. So we have several logic to convert the categorical into a number. Now you can see there is no categorical data. There is no alphabets or words. Everything is converted into a numbers. Right? Now our data set is good. So consider that if I use, okay, if I use all this 25, now it may be get changed too much. Let me see, nearly we have 28 columns. So if I create model for all these 28 columns, definitely this is going to be the worst case, right, for the customer. So we have to make this as a cost effective. So we are going for the feature selection method. So this is a select K best. Here you can see, here I have forward using the score function like chia square, and I'm giving the K value is equal to 5. How many I want? And this is the next one is RFE, the recursive feature elimination. So what are the concept I have discussed? Everything is involved here. So Python is a very good language, like your work will be very easy. So here I have used logistic regression. So instead of this logistic regression, you can try with decision tree, you can try with random forest, and you can try with all the algorithms you want to check with it, right? So let me run this. So here I'm going to try with only 2 feature selection, and I'm going to, after the feature selection of that input, I'm going to pass it to SVM, right? Then KNN. This is classification problem. So I'm using classification algorithms, then random forest, then, okay, or only random forest, 3 algorithm. So I have loaded all the procedures. So far, I have loaded only the procedures. I have created all the things as in a definition function, right? So now I'm going to segregate input value and output value. Independent value and dependent value, right? So first step, as a first step, let me zoom it. Right, as a first step, I'm going to select K algorithm. I'm pausing input variable and output variable. Okay. So in variable explorer, let's see what are the values it got selected. So I given 5. So from 0, it starts indexing from 0. So I have 0, 1, 2, 3, 4. So exactly it's selected from Okay, exactly, it's selected from the data set. Okay, so now RFE feature. So now in RFE feature, you can see because of logistic regression, it worked well on the 0 ones and 1s. Okay, now I'm going to apply. So let me take screenshot of this and I will explain you the table so that you will understand clearly. So what we are going to do is we are going to apply to SVM, KNN, then random forest. So I'm going to check with select K, then RFE algorithm. So when I apply the future selected by select K like 5 into SVM, it's going to produce me one model, and this model produce me one output. Like accuracy, for example, 98. And when I supply RFU same into this SVM, this is going to produce me one model 2, and for example 78. Again, I'm going to put the select K into a KNN. So I will get model 3, model 4, model 5, and model 6. I hope you got the flow, right? So by applying the select K to KNN, what accuracy you are getting? By applying RFE to KNN, what accuracy you are getting? So this is a table that you can, for understand clearly for one problem statement, nearly by using 3 combinations like 3 into 2, we have created a 6 model. So if you are in a research domain, if you have good data set and good problem statement, you can do many analysis, right? Even you can increase with the decision tree, then naive bias, and you can increase an RFE with, this is for logistic regression. Again, you can change the parameter and again you can enlarge your model. So for one problem statement, by changing the parameters, you can create many models. From that model, you can select your best one, right? So now let me run and show you the SVM. So SVM accuracy with select K is 0.95 and SVM with RFE feature is giving me 98%. Now we'll check for how random forest works with this feature selection. So 98 and 95 and 98. KNN, it's giving me 89 and 98. So based on this, I would select. So nearly SVM with RFE have worked well, like 98. And again, random forest with RFE is 98 and KNN with RFE is also 98. So you have the same scenario. Now, which algorithm you are going to choose? So I will choose the random forest because this is a tree type algorithm so that you can get for which reason this person is received positive or negative. So quickly I will tell you, I will show you the demo of implementation, how you can take this process into a next level. Activate. This is my virtual environment. Then column. Oh God. Python manage run server. I'm going to deploy and show you in the local server. So this is how you can take for consider that we are going to deploy the system into a hospital. Now I have reduced from 28 columns into the most important 5 columns. This is feasible, right? This is correct way of doing. So here I'm going to give some value randomly. I'm just giving. Right. So after entering this test result, we'll see whether this person is going to have positive or negative. So here you can see you will have the chronic kidney disease in the future positive. So this person is going to get positive if he has blood glucose random level like 443, blood urea level 45, 23 in these ranges of this test. So I have implemented the system with the random forest. So this random forest will tell me for which ratio this person received positive. So because of serum creatine, SE is serum creatine is 23. Because of this range, there is a possible of he is getting 90% of chance that he is getting positive. Right? So my suggestion is when you go for classification, you can either choose if you get the same result for SVM, KNN, you can go for decision tree or random forest. When you have tree-like algorithm, you can draw such type of graph. Exactly, you can know for which ratio he is most vulnerable to get positive. Right? So, is there any doubt? Is there any doubt? So this is all about how you can do the future selection. So quickly, I will show you how PCA works. Just I will show you the so let me take the new kernel. So up to this is same process. Then here you can see from Scalar, we are taking PCA. Here I'm giving component as 2. I need 2 principal component, right? So here I have changed the X-train and X-test into a full form, like from the PCA form. Now we'll check how X-train and X-test looks like. So here you can see the value is fully changed. There is no value as such in a data set. So instead of so many data set, you can work with it PCA also. Right? So for any doubt, so again same concept, only part you have to change here for PCA, LDA, then kernel PCA. Any doubt? If you have any doubt, you can type it in the comment box and you can give feedback of this particular session. So after 11:30, we'll see the deep learning concept. How artificial neural network works in that way.
Ma'am, I think no doubts from participants. Shall we give break, ma'am, half an hour?
Yes, sir. Yes, sir. Sure, sir.
We'll start 11:30, ma'am, exactly.
Yeah, yes, sir. Sure, sir.
Okay, thank you, ma'am. Thank you for the nice presentation.
Thank you, sir.
Participants, you come with 1:30. This is the time for break. Half an hour you take break. We'll exactly start at 11:30. Thank you, participants.